Ever get, like, totally annoying notification that your phone storage is full? Ugh, it's the worst. But what if, like, all the data in the Library of Congress could be stored on something smaller than a grain of rice? That's what scientists are working on with crystal storage. And it's not magic, even though it kind of sounds like it. It all comes down to using imperfections in crystals, specifically missing atoms. These tiny gaps, they act like little memory cells. And by manipulating them with light, scientists can store tons of information. So think of it like a grid that's perfectly arranged but with a few blank spaces. That's basically our crystal lattice with its missing atoms. Each missing atom can represent a bit like a 0 or a 1. And that's how computers talk, right? Now, because atoms are so small, you can fit a crazy number of them into a tiny space. We're talking terabytes, millions of megabytes in something you can barely even see. This isn't just about, fitting more cat videos on your phone, though. The really cool thing is how durable these crystals are. They're super resistant to damage, way more than like our hard drives and flash drives right now. We could be talking about storing data for millions of years, like a digital time capsule. But how does it actually work? Well, it's because of the unique properties of these things called rare earth elements. They're also called lanthanides. And they have these special electronic transitions that let them be controlled with light. So picture this. You shine a specific wavelength of light on a crystal, and it's infused with these rare earth ions. The ions get all stimulated, release electrons, and then those electrons get trapped in our memory cells, the missing atoms. And by controlling which defects get charged with these electrons, we can actually write information onto the crystal. It's basically like using light to etch data onto an atomic canvas. So how do we actually read the information that's stored in these crystals? Well, it's like using light again, but this time it's to detect like whether or not there's an electron trapped in those tiny atomic gaps. It's kind of like a microscopic version of Braille. Where the smooth surface is like our crystal lattice and the raised bumps are the missing atoms that are holding all the information. And just like Braille can be read by touch, these atomic bumps, they can be read by light. So shine a laser on the crystal, and you can actually tell if a specific memory cell is holding an electron. And that reveals whether that bit of information is a 0 or a 1. But the cool thing about crystal storage is that it's not just about how durable it is. Remember all those massive data centers that power, like, everything in our digital world? Well, they eat up tons of energy and they generate a lot of heat. But with crystals, reading and writing data actually uses way less energy than the old ways of doing things. So imagine like the impact this could have on energy consumption and cutting down on all that heat. It's a huge step towards being more sustainable. And then there's the size things, right? I mean, we're creating more data now than ever before, and it's becoming a real challenge to store it all. But with this technology, we could like condense entire libraries, archives, even massive databases into these teeny tiny crystals. The possibilities for making things smaller are just mind-blowing. Of course, like any technology, it's not perfect, and crystal storage still has some things to work out. One of the big ones is speed. Right now, reading and writing data to these crystals is still pretty slow compared to our hard drives and flash drives. But scientists, they're always trying to make things faster, and the potential here is just too big to ignore. Like, think about it. We could be on the edge of like a whole new world where information is stored, and it lasts as long as the crystals themselves. Imagine a future where all of human knowledge is like stored in these crystals. All our history, art, scientific discoveries, and they're just like tiny pebbles. It would be like this crazy treasure trove of information that could last for millions of years. It'd be like a legacy for, whoever comes after us. It's kind of like building a digital pyramid, right? This monument to like everything we know, but it outlasts any building we could ever make. And it's not just about preserving the past either. Crystal storage, it could totally change how we collect and analyze data in the future too. Think about all that information that's being created every second, from scientific instruments, telescopes, medical devices. With crystal storage, we could like grab all that data and keep it safe forever. It could lead to like huge breakthroughs. In medicine, astronomy, climate science, it'd give researchers access to like way more information than they've ever had before. And on a personal level, like imagine this. All your memories, photos, videos, your whole digital life. It's all on this tiny crystal that you could pass down, like a family heirloom. It would be a way to like share your own history with, your kids and their kids and so on. And it would last forever. Crystal storage is still pretty new, but the possibilities are just, I don't know, they're amazing. Like, we're looking into a future where the only limit to how much we can store is is our imagination.